Good morning, kids. It's Mr. Agee here. I'm here to talk with you about your math work for today, Friday, November 13th. It is Friday the 13th. So the CAMI versions of the document can be found in the Math 13, or in the Week 13 Math and Word Study folder with Agee. You'll want to click into Math and the the lesson problem set is here. I haven't put the homework in there yet, but I'm going to put it in right after this video. But I want to show you what you're going to be focused on today. You are going to be doing another example of trying to compare estimates to actual differences. So when we're talking about differences, remember we're talking about the answers to subtraction problems. So they give us two columns of related problems. Here in column A, all the problems are roughly 450 minus 150, and they're showing us when you round one of the numbers down and one of the numbers up, you'll get an estimate that's closer to the actual answer. But if you round them, like in this example, 451 minus 153, they're both going to round up to the nearest hundred. The estimated difference is going to be far away from the actual answer. And so that's what they're trying to illustrate here. For me, the main thing is get lots of practice with using the standard algorithm for subtraction with borrowing. I'm not going to ask you to do problem B here. I feel like it's a little convoluted. If you want to try it, feel free, but I'm fine if you just skip over this part and then move on to the problems, okay, and the problems. And I'm going to go through modeling this with you, and then most of the work that you're going to have to do today is going to be focused on the homework. So the through this mini lesson here and the work that we do together, assuming CAMI works today, you will be able to have most of this problem set complete but as you're starting your independent work time. So let's just start by doing some of these practice problems here. And so I'm going to move into my drawing tool, and we start in the ones, and I recognize right away that I don't have to borrow in the ones. I will have to borrow in the tens. I can just look ahead. I'm going to have to borrow in the ones, and because I'm borrowing in the ones, I'm going to have to borrow in the tens because this is going to end up being a 4 in this problem. So I'm going to have to double borrow in this one. I'm going to have to borrow in the ones, I'm going to have to borrow in the tens. So this is another double borrowing problem. Here I'm going to have to borrow in the ones, but not in the tens. So that's a kind of a fancy little way to look at it ahead of time to see, okay, what am I going to need to do before I even start this problem? Okay, so 8 is greater than 3. I can subtract 3 from 8. That gives me 5. 4 minus 5 is not something I can do using the standard algorithm. I can use I can do that problem using just like a number line or mental math, and I recognize that it's a -1, but -1 isn't going to work in this standard algorithm. So 14. So I'm gonna take one of those hundreds. I'm gonna transform it into 10 tens and move it over into the tens place, and that gives me 10 tens to add to the 4 tens that were already there. 14 tens minus 5 tens gives me 9 tens, or 90. 3 minus 1 gives me 200s. Okay, so I'm going to use text boxes over here to fill in all this stuff when I'm done. 1 minus 3 puts me in the negative, so I'm going to transform one of these 10s into 10 ones, and that gives me 11 ones because I already had one there. So 11 minus 3 gives me, oh my gosh, that's going to be so let's see. It's not easy to do. I'm sure you have probably figured that out. Um, Here's my 8. 4 minus 5. Okay, so here's where things can get a little tricky. I'm going to use Audrey's method here to just stick that 10 right in front of the 4. So I've got 4 hundreds here. I'm going to take one of those hundreds and I'm going to turn it into 10 tens. And so I can put that 10 tens directly into the 4 tens that are already there to get 14s. This is going to be 9. And now I've got 2 hundreds. So you can see these numbers are pretty close together. They should all be pretty close together because, as I said, if you look, it's 450. It's roughly 450 minus 150, 450 minus 150, 450. If we were rounding to the nearest 10, each one of these problems would be 450 minus 150. But they tell us to round to the nearest 100. So that really changes things here. So you can see that if you round to the nearest 10, you're going to get a more precise difference compared to rounding to the nearest 100. Okay, 8 minus 9, I'm not going to be able to do that. This is going to be another double borrowing problem here. So I've got 18 and 8. That's going to be, yep, 18 minus 9 is 9. 3 minus 4, got a little bit of trouble there. So I'm going to take 100 and transform it into 10. 13 minus 4 here is going to be 9. I'm sorry, it's not going to be 9. 13 minus 4 is going to be 5. It's a little bit early in the morning for me here, guys. 5 and 3 minus 1 is going to be 2. Okay, so again, it makes sense that I'm near 250. This one actually rounds up to 260. And the last one here, we've got, I'm going to have to borrow and add 10 ones. 11 minus 9 is 2. 4 minus 4 is 0. 4 minus 1 is 3. I did something wrong here. 451. Okay, 11 minus 9 is 2. 450 minus 150. Yes, I did something wrong here. I was right the first time. I apologize. My brain's just not clicking yet. I was right the first time. So 13 minus 4 gives me 9. So we're right around 300 each time. So if I said we were right around 250 each time, that's my mistake. 450 minus 150 is roughly 300. And so each of our actual differences show that. So here, I'm going to have to shrink this down a little bit to 14er. And so I'm just going to type in the responses that I got on the right, on the left there. So here I've got 298, and here I've got 299, and here I've got 302. All right, and now so for the rounding portion, 448 rounds down to 400 because it's lower than 50. 153 rounds up, so it's going to be 200. 400 minus 200 is going to be 200. Nope. Here we've got 450 rounding up to 500, 150 rounding up to 200, 448 rounds down to 400, 149 rounds down to 100, and 451 rounds to 500 when we're rounding to the nearest 100, and 100 rounds to 149 rounds to 100. Okay, so 500 minus 200 is 300, and 400 minus 100 is 300, and 500 minus 100 is actually 400. I think I said the wrong thing at the beginning of this lesson. So looking at this, it says circle the estimated differences that are closest to the actual differences. So when we would circle these, we're looking for something near 300, or at 300. So these two actually would be the ones, and I think in the beginning I said it was like the addition one where when you round one up and one down, you get closer, but I think it's actually opposite. So I rounded the first number down here to 400 and the second number up, and I get a number that's pretty far off. And in the bottom example, the same thing happened. I rounded up with the first number and down with the second number, so I get a number that's nearly 100 off. In both of these examples, I round the first number and the second number up, and I get closer to the actual difference, and here I round the first number and the second number down, and I get closer to the actual difference. So I think what's happening is, like, as you shift by rounding both numbers up, you keep the difference relatively the same. If you have one number that goes up and the other number that goes down, what you're doing is you're stretching the difference out. If the first number goes up and the second number goes down, you're stretching that difference out and making it larger, like in this example here. Or if you're making the first number smaller and the second number bigger, you're shrinking the difference. That's actually what's happening there. So I said the wrong thing at the beginning. Forgive me. I'm not going to restart this video because I'm 10 minutes in. And you know, in math, this happens. We discover things as we go, and I had the wrong idea going into this at first, but we got to figure it out. So. The big idea is we're practicing using the standard algorithm to subtract. We're also practicing rounding to the nearest hundred and then analyzing what it looks like to compare these differences to the actual differences to the estimated differences. I'm going to leave this section B for you to do on your own. Down here, I'll do one of these now, and then we'll save one for when we work together. Okay, so the big idea here is we're taking our word problem, we're mapping it out using math drawings and making sense of it the best that we can with those drawings and models and whatever strategies we've been working on. So in number 2, Camden uses a total of 372 liters of gas in 2 months. He uses 184 liters of gas in the first month. How many liters of gas does he use in the second month? Okay, so we've got a total of 2 months gas here, 372 liters. The first month he uses 184, so we've got a missing part. When you put these two parts together, first month, second month, you get the 2 months. And when we have a missing part, we know that we can subtract to find that missing part, because if we had both of the parts, we could add them together to get the total. Excuse me. But since we're missing a part, we're going to start with the total and take out the part that we know to find the part that we don't know. And it asks us right off the bat here to estimate the amount of gas Camden uses in the second month by rounding each number as you think best. So I think that what we've discovered over these few estimation lessons that we've done is that when you round to the nearest 10, you get closer because you're not changing the numbers as much. Just for the sake of demonstrating that, let's do both of them. Let's round to both numbers to the nearest 10 and round to the nearest 100. So I'll do 370 minus 180, and that equals, so I could count down by 100, that's 270, and then down by another 100 would be 170, and then I have to go back up. So I went down by 200, and now I have to go back up by 10 to get to 180, so that would be a difference of 190. Then the other way, I would round to the nearest 10, 400 minus 200, and that gives me 200. So they're both really, really close to each other, and we won't know exactly what the difference is until we actually do the subtraction. So I've set up the problem here. How many liters of gas does Camden actually use in the second month? Model a problem with the tape diagram. So here's a tape diagram. I start with the total. I put the part that we know, which is over half. I know that it's over half. 18 and 18 makes 36. So 180 and 180 would be 360. So I can see that this is just slightly over half. 372 minus 184. I've only got a minute left here, so I'm going to have to buzz through this. 2 minus 4, I'm going to struggle with that because this algorithm's not built for it, so this ends up being a 6. Here we've got 12. Okay, so, oh man, that's an ugly 2. 12 minus 4 is 8, which is really hard to draw on this. There we go. 6 minus 8, can't do that. So I've got 2 hundreds. I'm going to transform 100 into 10 tens. That makes 16 tens. Minus 8 is 8. And 2 minus 1 is 1. So you can see the actual difference is 188. So in that second, sorry, that was in that second problem, we find out the actual difference is 188 liters. Compare it to 190 and 200, and you can see